The last time a storm on Earth reached the pressure a handful of models were quietly printing for Bavi, the year was 1979, and the storm was called Tip. Those model runs whispered a number that made the people who watch this for a living go quiet. 871 hectopascals, a reading the planet had not touched, not once, in over 4 decades. If it happened, Bavi wouldn't just be a bad storm in a bad season. It would be the strongest tropical cyclone ever measured on the surface of this world. And it would be aiming that strength squarely at American soil. So here is what actually happened. Whether that number came true, whether Bavi ever became the record it was rumored to be, and what really landed on the northern Mariana Islands when the eye finally arrived. I'm going to show you what was real, what was worst case, and where the line between them ended up falling. Because with a storm like this, those two things get blurred within hours, and the truth is stranger and more sobering than either the panic or the dismissal. If you follow storms like this, if you want to understand them while they're still forming, before the headlines catch up and before the context gets stripped away, subscribe and hit the like button. That's genuinely how these breakdowns reach more people. And we track these systems as they unfold, not a week after they're gone. Now, let me take you back to the moment the internet actually noticed Bavi. Because it did not start as a monster. It started as almost nothing. A few days before it became a household name in the Pacific, Bavi was a tropical storm sitting over open water east of Guam, moving west-northwest with winds somewhere around 60 miles per hour. On paper, that's a system you'd note and move on from. 60-mile-per-hour winds will knock down tree limbs and make you close your shutters. They will not level a town. If you'd scrolled past the satellite loop that morning, you'd have seen a loose, disorganized swirl. A lot of cloud, not much of a core. Nothing about it screamed record. And that is exactly the trap. Because the forecasters were not looking at the number. They were looking at the slope of the curve. Here's what I mean. The thing that terrifies a hurricane specialist is not where a storm sits today. It's how fast that dot is climbing and what's waiting in front of it. Bavi was over a stretch of the western Pacific that is, functionally, a factory for the strongest storms this planet produces. The water was warm, around 29 to 30 degrees Celsius, which is roughly 84 to 86 Fahrenheit. Bath water you'd happily sit in for an hour. But warm at the surface isn't enough. What matters more is how deep that warmth goes. And here, the ocean was warm to a great depth. The heat content of that water column was over 110 kilojoules per square centimeter, which is a technical way of saying the storm had an enormous fuel tank underneath it that it could not drain, could not stir cold water up from below, could not choke itself. And above it, the winds were quiet. Only 5 to 10 knots of shear. That's the part that lets the top stay stacked neatly over the bottom, instead of getting sheared apart like a tower of blocks pushed sideways. Warm, deep water. Calm air above, nothing in the way. Every ingredient a tropical cyclone needs, all present at the same moment, all at once. When a forecaster sees that alignment sitting in front of a storm that's already organizing, they don't relax. They start clearing their calendars. And Bavi did exactly what that setup promised. It didn't strengthen. It detonated. In the 24 hours ending midday that Friday, Bavi's winds climbed by 75 miles per hour. Let that sit for a second. The official threshold for what meteorologists call rapid intensification, the technical alarm bell, is a 35-mile-per-hour jump in a single day. Bavi more than doubled that. And if you widen the window to 36 hours, it had gained 100 miles per hour of wind speed. That's the difference between a storm you shrug at and a storm that can peel the roof off a concrete building. And it happened over a span shorter than a weekend. By 2 in the afternoon, Eastern Time, on July 3rd, Bavi crossed the line into Category 5 equivalent strength, with winds near 160 miles per hour, according to the Joint Typhoon Warning Center. It had become the world's third Category 5 tropical cyclone of 2026. Yesterday, a 60-mile-per-hour tropical storm you'd barely note. Now, one of the most powerful storms on the planet. Same system, same name, a completely different animal. That is the moment the internet noticed. Not the 60-mile-per-hour swirl, the explosion. And once a storm like that appears on the satellite loop, with a clean, wide eye punched through the center of it, everything downstream changes at once. The warning centers switch their language. The military bases in its path start moving aircraft. And the model output, the raw numerical guidance that normally stays inside the meteorological community, starts leaking out into the wider internet, where the most extreme printout of all gets grabbed and shared with all the caveats sanded off. Which brings us to the forecast that actually made people stop scrolling. When a storm reaches Category 5, the question stops being, will it be bad, and becomes, how close to the physical ceiling will it get? And here I need to be careful with you, because this is exactly where two different official agencies put two different numbers on the very same storm. And if you don't understand why, the whole thing looks like chaos or a cover-up. It's neither, it's just measurement. The Joint Typhoon Warning Center, the American agency that watches this part of the world, was forecasting Bavi to peak with winds around 175 miles per hour early that Sunday. It expected the storm to slightly ease afterward, not because the ocean was running out of fuel, but because of something called an eyewall replacement cycle, a natural process where a big storm's inner wall of thunderstorms collapses and a new, wider one forms around it, temporarily broadening the storm and taking a little edge off the peak wind before it can re-intensify. Think of a figure skater, pulling their arms in to spin faster, then flinging them out again. The spin slows for a moment before it can tighten back up. At the same time, the Japan Meteorological Agency, the agency that holds official warning responsibility for the entire Northwest Pacific, was estimating Bavi's central pressure at 935 millibars, with winds of 110 miles per hour. And later that pressure fell to around 920, then 910. So one agency says 175, another says 110. Same storm, same hour. How? Here's the honest answer, and it's simpler than it looks. They're not measuring different storms. They're using different stopwatches. The American Center reports the fastest 1-minute average of the wind. The Japanese agency reports a 10-minute average. Wind isn't a steady thing. It gusts and lulls, gusts and lulls. If you clock the single most violent minute, you get a big number. If you smooth it out over 10 minutes, the peaks and valleys average each other down, and you get a lower one. It is the same wind. It's just the difference between measuring the fastest single stride of a sprinter and measuring their pace over a lap. Neither is wrong. You just have to know which stopwatch you're reading before you compare. And that's why the pressure matters so much in this story. Because pressure doesn't care about your stopwatch. It's a single, clean number you can read straight off an instrument, and everyone agrees on it. As Bavi tightened, its central pressure fell and fell. 935, then 920. Then, by that Saturday, satellite estimates and other data were showing 910, and the imagery revealed a wide, well-defined eye, about 25 nautical miles across, punched clean through the heart of the storm, like the pupil of an eye staring straight up at the satellites. Maximum sustained winds were being pegged as high as 178 miles per hour, with the storm sitting only about 137 miles east of Andersen Air Force Base on the northern tip of Guam. 137 miles. For a storm whose hurricane-force winds already stretched nearly 60 miles out from its center in some directions, that is not a comfortable distance. That is a storm reaching out toward land. And it was still falling, every reading lower than the last. Which is the exact moment those model runs started whispering a number that hadn't been possible on paper in most of the audience's lifetime. A number that, if you pulled it out of context and put it in a headline, would look like the planet was about to break its own record on live satellite. That number was 871. And where it came from, and what it actually meant, is where this story turns. So let's talk about 871, because that single figure did more to shape the public panic around Bavi than any official bulletin ever did, and it came from a very specific place. When forecasters build a picture of where a storm is headed, they don't rely on one crystal ball. They run dozens of computer models, and inside each of those, they often run the same model many times over, with tiny variations in the starting conditions, a nudge here, a slightly warmer patch of ocean there. It's called an ensemble, and the point is to see the spread of possibilities. Most of those runs cluster together in a reasonable range. That cluster is what becomes the forecast. But out at the far edges, you'll almost always find a couple of runs that go somewhere wild. One that keeps the storm weak, and one that takes it to the absolute physical limit of what the atmosphere could theoretically allow. 871 was that far edge run. It was the single most extreme printout in the entire spread, sitting way out at the tail, at the very boundary of what's called reliability, the point past which the model is essentially guessing at physics it can't actually resolve. It was one solution, at long range, at the outer wall of what's credible. Not the forecast, the nightmare corner of the forecast. And here's the trap that swallows these numbers every single time. When 871 lives inside a meteorologist's ensemble display, surrounded by 50 other runs and clearly labeled as an outlier, it means something honest. This is the worst the physics might barely permit. But the moment that number leaves the model, the moment someone screenshots it and posts it with 3 exclamation points, every bit of that context falls away. The 50 other runs vanish. The word outlier vanishes. What's left is a naked figure, 871, next to the sentence, "Strongest storm ever recorded is coming." And that's not what the data said. That was never what the data said. Let me be honest with you about what that number was and what it wasn't. It was not a promise. It was not even the official forecast. The actual guidance from the warning centers had Bavi peaking with a central pressure well above that, in the low 900s and later the 8-900s, which is already a monstrous, catastrophic storm, but a world away from the all-time record. The 871 was the atmosphere's theoretical basement in one extreme simulation. And treating it as an expectation is like reading the fastest lap a car has ever physically achieved and assuming that's the speed limit on your street. The number was real in the sense that a computer produced it. It was fiction in the sense that anyone treated it as what would happen. But, and this is the part that keeps it from being a simple "don't worry" story, the fact that a credible model even flirted with that basement tells you something. It tells you the ocean underneath Bavi held enough raw energy that the storm's true ceiling was genuinely unknown. When you cannot confidently measure the ceiling, the responsible move is not to dismiss the high end. It's to prepare for it. And the people living directly under that storm did not have the luxury of arguing about model reliability. because they were the ones the arrow was pointing at. So who, exactly, sat in the path? The Northern Mariana Islands and Guam. And to understand why this was so serious, you have to understand what these places actually are. Guam is the largest, home to around 153,000 people, plus the enormous American military presence at Andersen Air Force Base and Naval Base Guam. To the north, the Commonwealth of the Northern Mariana Islands, Saipan, Tinian, Rota, and a scatter of smaller islands, holds roughly 47,000 more. Added up, and you have something close to 200,000 people living on specks of land in the open Western Pacific. And here is the brutal geography of it. Saipan is about 12 miles long and, at its widest, roughly 5 miles across. Tinian is smaller still. When a storm bears down on the Gulf Coast of the United States, people can drive inland, put 50, 100, 200 miles between themselves and the water. On an island a few miles wide, there is no inland. There is no interior to retreat to. The center of Saipan is a 15-minute drive from the coast in any direction. The whole island is coast. When a super typhoon comes, you don't outrun it. You get into the strongest concrete structure you can find and you wait, and you hope the roof holds. And these islands know exactly what that feels like, because they've done it before. Recently, more than once. In October 2018, Super Typhoon Yutu, one of the most intense tropical cyclones ever to strike United States soil, made a direct hit on Tinian and Saipan, with the eye passing right over them. It flattened homes, tore the roofs off schools, and left the islands without power for weeks. People who lived through it described the sound of the wind as something that doesn't stop, a scream that goes on for hours. Before that, Typhoon Sodalor had raked Saipan in 2015. Guam itself carries the long memory of Typhoon Pongsona in 2002 and Typhoon Karen back in 1962. This is ground that has been beaten before, that has rebuilt before, and that knows the drill in a way most places never have to. So when Bavi exploded to the east and the models started printing record numbers, nobody on those islands was treating it as a spectacle. They were boarding up. Now let me show you how the transformation actually works. How a 60-mile-per-hour tropical storm becomes a Category 5 monster in the span of a couple of days. Because once you see the mechanism, the fear makes sense, and so does the caution. At the heart of every tropical cyclone is a simple bargain. The storm is a heat engine. It pulls warm, moist air up from the ocean surface. That air rises, and the water vapor in it condenses into towering thunderstorms. And condensing water releases heat, an enormous amount of it. That heat warms the core of the storm, and warm air is lighter, so the pressure at the center drops. Lower pressure at the center means air rushes in harder from the surrounding higher pressure air to fill the void. Air rushing in is wind. The lower the central pressure, the steeper the drop between the outside and the eye, and the faster that air has to move to slide down the slope. That's the whole engine, in one loop. Warm water feeds heat, heat drops the pressure, low pressure drives the wind whips more moisture off the ocean, which feeds more heat. Round and round, tightening on itself. Think of the pressure difference as the steepness of a hill, and the wind as water running down it. A gentle slope, a lazy trickle. A cliff, and the water screams down. When Bavi's pressure fell from 935 to 910, and the models were reaching toward the 890s, that hill was getting brutally, dangerously steeper by the hour. Rapid intensification, that phrase you keep hearing, just means the storm found itself over a stretch of ocean where the engine could run flat out, with nothing holding it back. Warm water to a great depth so it couldn't stir up cold from below and starve itself. Quiet winds aloft so the top stayed stacked over the bottom and the heat couldn't leak out sideways. Moist air all around so no dry pockets got dragged in to snuff the thunderstorms. When all of that lines up at once, the engine doesn't just idle, it redlines.
And a storm can gain 100 miles per hour of wind in a day and a half, which is exactly what Bavi did. The frightening thing about rapid intensification isn't just the strength, it's the timing. A storm that blows up in the final day before landfall gives the people underneath it almost no runway. You go to bed with a strong tropical storm offshore and wake up to a Category 5 bearing down. And by then, the window to prepare has already closed. It's the reason forecasters lose sleep over these fast-developing systems in a way they don't over the slow, telegraphed ones. Which brings us, finally, to Tip, and to 870, and to why that number was even on the table in anyone's imagination. In October 1979, over the Western Pacific, a typhoon named Tip became the most intense tropical cyclone ever measured on the surface of the Earth. A reconnaissance aircraft flew straight into it and recorded a central pressure of 870 hectopascals. Not estimated from a satellite, not modeled, measured by an instrument inside the storm. That number has stood unbeaten for over 46 years. But the pressure is only half of what made Tip legendary. It was also the largest tropical cyclone ever recorded. Its circulation stretched around 1,380 miles across, wide enough that if you'd centered it over the United States, it would have covered nearly half the country in one storm. Its winds peaked near 190 miles per hour. It was a storm so vast, the aircraft crews described flying into it as flying into a different planet's weather. Here's why 870 will probably never be beaten on paper, and it has almost nothing to do with the atmosphere. It's about how we measure. In 1979, the United States routinely flew reconnaissance aircraft into Western Pacific typhoons, physically penetrating the eye to drop instruments and read the pressure at the core. That program ended in 1987. Today, almost every typhoon in that basin, Bavi included, is estimated from satellites, using a technique that infers the storm's strength from the pattern and temperature of its clouds. And no aircraft flies into these storms to check. Which means that even if a modern typhoon truly did drop to 869 in its heart, there would very likely be no instrument in there to catch it. The record isn't just hard to beat, it's hard to even verify anymore. So when the models whispered 871 for Bavi, they weren't just forecasting an extraordinary storm. They were reaching for a ceiling that one aircraft touched, once, in 1979, over the same ocean. A ceiling we can barely measure and may never confirm again. The question was never really whether Bavi could reach that basement. The question was, what would actually arrive when the eye finally closed the last 100 miles to the islands? Because the frightening early guidance and the storm that showed up at the doorstep are not always the same thing. And the gap between them is where this story finally lands. The last 100 miles are where all the modeling and all the arguing finally stop mattering. Because the storm either turns toward the islands or it doesn't. And Bavi's eye, that clean, wide pupil punched through the center, did not go straight over Guam. It tracked to the north of it. At its closest approach, the center of Bavi passed well to the north of Guam and then threaded between the islands,
staying offshore of the most populated ground rather than driving the eye directly across it. The northernmost islands of the Marianas caught the worst of it, but the direct, eye-over-the-rooftops catastrophe that Yutu delivered to Tinian in 2018, that specific nightmare, did not repeat here. And that distinction is everything, because in a tropical cyclone, the violence is not spread evenly. It's crammed into a ring. The most destructive winds live in the eyewall, the wall of thunderstorms circling the calm center, a band often only 20 or 30 miles wide. Miss the eyewall by 50 miles and you feel a serious, dangerous storm. Take the eyewall directly overhead and you feel something that can strip a concrete building down to its rebar. Bavi's worst ring passed offshore of the biggest population centers. So what did the islands actually feel? Strong, dangerous conditions, damaging winds, torrential rain, coastal surge, and pounding surf along the northern and eastern shores. The kind of storm you take shelter from and do not step outside during. But not the flattening, weeks without power devastation that the frightening early guidance had put on the table. The gap between the worst-case whisper and the storm that arrived turned out to be wide. The people who boarded up and sheltered did exactly the right thing, because at the moment they had to decide, nobody could promise them the eye would turn north. That's the honest shape of these events. You prepare for the high end of what's credible, and sometimes the credible high end doesn't come for you. That's not a failure of the warning. That's the warning working. Now, the question everyone actually clicked for. Did Bavi become the monster? Did it get anywhere near 871? Here's the honest verdict, without dressing it up in either direction. Bavi was, genuinely, one of the most powerful storms of its year. It reached Category 5 equivalent intensity, with peak 1-minute winds estimated near 175 to 180 miles per hour by the Joint Typhoon Warning Center, and a satellite estimated central pressure that bottomed out in the low 900s to upper 8/900s at its most intense. That is a formidable, dangerous, top-tier super typhoon by any measure. If it had driven that eyewall over Saipan, we'd be talking about a disaster. But 871? No. Bavi never came close to the 1979 record. The gap between where it actually bottomed out and the 870 that tip touched is enormous. We're talking about a difference of roughly 20 to 30 hectopascals, which in the physics of these storms is not a rounding error. It's the difference between a very intense typhoon and something the planet has recorded exactly once. The outlier model run that whispered 871 was, in the end, exactly what an outlier run is. The far tail of the possibilities. The corner the atmosphere could theoretically have reached and simply didn't. The official guidance, the boring middle of the ensemble that never went viral, turned out to be far closer to the truth. It usually is. That's the whole reason it's the official guidance, and the screenshot isn't. And any clean comparison to 1979 was always going to be unfair, for a reason that has nothing to do with how strong Bavi got. Because we could not actually measure it the way we measured tip. This is the part I want you to sit with, because it's the strange, unsettling core of the whole story. Every number you heard about Bavi's pressure, the 935, the 910, the 890s, was an estimate, not a reading. It came from satellites looking down at the pattern and temperature of the storm's clouds and inferring, through a well-tested technique, how strong the core must be. It's good science. It's also indirect. TIPS 870 came from an aircraft that flew into the eye in 1979 and dropped an instrument that read the pressure directly, at the core, with a physical sensor sitting inside the storm. Nobody did that with Bavi. No plane penetrated it.
The routine reconnaissance flights into Western Pacific typhoons ended back in 1987.
So think about what that means. Even if Bavi, in some brief window, dropped lower than the satellites could resolve, even if for 1 hour its true core touched something startling, there was no instrument inside it to catch the number. When you cannot directly measure the floor, you are left estimating it from the outside, and the uncertainty runs in both directions. That's not a reason to inflate the storm into a record it didn't earn, but it is a reason to treat the upper estimates with respect rather than dismissing them. The absence of a direct measurement doesn't mean the storm was weaker than we thought. It means we genuinely don't have the last decimal, and honesty requires admitting that instead of pretending the satellite gave us certainty it can't give. Which is exactly why, every time a storm like this appears, a second storm forms right behind it online, the one made of theories. So let me answer those directly, because the people asking deserve a straight answer, not a smirk.
The first theory is always that someone made this storm, or steered it.
That some installation or beam or hidden program cranked Bavi up or aimed it at the Marianas. I understand why that feels plausible when you watch a 60-mile-per-hour swirl become a Category 5 in a day and a half. It looks engineered. It wasn't. And the reason is scale. A mature typhoon is releasing heat energy at a rate on the order of hundreds of times the entire electrical generating capacity of the human race. Every hour it exists. Bavi wasn't sipping energy. It was pulling it out of a slab of ocean warm to a great depth, hundreds of miles across, and converting the heat of that water into wind. There is no human installation, no antenna array, no device on Earth that creates or redirects a heat engine the size of a sea. We can't even nudge a thunderstorm on purpose. The idea that anyone steered Bavi is not a question of secrecy. It's a question of physics we are nowhere close to. You can't push something you can't even lift.
The second theory is that the real strength was hidden, that authorities knew it was worse and covered it up. But look at how this actually played out. The terrifying 871 didn't come from a leak. It came from a public ensemble that anyone could pull up. The warning centers published their forecasts openly, in advance, with the wind numbers and the pressure and the track. The very fact that you heard about the worst-case model run at all is proof of the opposite of a cover-up. The extreme scenario was out in the open, being argued about in real time, days ahead. A cover-up hides the scary number. What actually happened is that the scary number was broadcast to everyone, and then, thankfully, didn't come true. That's transparency, not concealment. And the third, that a solar flare or space weather secretly powered the storm. Space weather is real, and it's dramatic, but it deposits its energy high up, in the upper atmosphere, and out in near-Earth space, hundreds of miles above where weather lives. Hurricanes and typhoons run on ocean heat, in the bottom few miles of the atmosphere. A solar flare doesn't warm the sea surface Bavi was feeding on any more than a lightning storm on a distant mountain warms the soup on your stove. Different system, different altitude, no connection. So take all of this, and let me tell you what to actually watch next time, because there will be a next time. And now you have the tools to read it before the headlines strip out the context. Watch the slope, not the snapshot. A modest storm over deep, warm water with quiet winds aloft is a storm about to run. The number today matters far less than how fast it's climbing and what's waiting in front of it. Watch the pressure, because it's the one figure everyone agrees on, and it can't be gamed by which stopwatch you use to average the wind. And when you see a jaw-dropping number like 871 fly past, ask one question before you share it. Is this the middle of the forecast or the far tail of it? Is this what the warning center is telling people to prepare for? Or is it the single most extreme run in an ensemble, screenshotted with the context sanded off?
9 times out of 10, the viral number is the tail. The boring official guidance is the truth. Here's the honest bottom line on Bavi, and you deserve both halves of it. Bavi was a genuine super typhoon, a Category 5 that exploded over the Western Pacific and forced 200,000 people on some of the most exposed islands on Earth to shelter and prepare. And they were right to. That half is real, and it was serious. And the other half, it never became the record. It never touched 871. And the comparison to Tip in 1979 was never fair. Both because Bavi bottomed out well above that floor, and because we could never have measured it the way we measured Tip anyway. The record from 1979 still stands, over the same ocean, untouched, a pressure one aircraft read once before we stopped flying into these storms to find out. That's the strange truth these events keep teaching. The scariest number is almost never the real one.
But the ocean that could produce the scariest number is real.
It's warm to a great depth, and it's still out there. And the next storm is already forming somewhere over it while we talk. If you want to understand these systems while they're still just a swirl on the satellite loop, before the record whispers start, before the context gets stripped away, subscribe and stay with these breakdowns. We track the storms as they unfold. We separate the tale of the forecast from the truth of it, and we tell you both halves every time. The next Bavi is out there. When it starts to climb, you'll want to already know how to read it.